This is a video on factoring by grouping. The first thing you want to notice when you're factoring by grouping is that you're going to use this only when you're factoring an expression that contains 4 terms. So that's what's really tipping you off to using this method. I'm going to start with an example, and then later on I'll take you through a step-by-step process. So our example says to factor ax plus ay plus bx plus by. And when you're factoring, the first thing you should always look for is a greatest common factor. And you need a greatest common factor for the entire expression. In this case, we have ax plus ay plus bx plus by. All 4 terms do not have a common factor. There's nothing that we can factor out of all 4 of them. This is where factoring by grouping comes into play. If you can't factor anything out of all 4 terms, what you really want to do is you want to factor something out of each set of 2. So you're going to make 2 groups of 2. Alright, so we got a first group of 2 and a second group of 2 here. And from the first group of 2, we're going to factor out a GCF equal to, well, ax and ay, the only factor they have in common is a. So we're going to factor out a GCF of a here. And for the second group of 2, bx and by, the only factor they have in common is b. So we're going to factor out b here. And so if we're factoring this out, this is going to be equal to, from the first group I'm factoring out a, and then in my parentheses what's left over, if I factor out an a from ax, I'm really dividing out the a, so you're left with x, plus ay factoring out an a, it means you're really dividing out an a, you got x plus y in parentheses there. And now we're going to factor a b out of the second group. Now since this is a positive b, right, and it's based off of this sign being a positive, alright, it's always the first one there. Since we're factoring out a positive b, we're going to write plus b. So the sign comes along with what you're factoring out, and it's based all on that first sign. So I'm factoring out b, and then in my parentheses, you're just dividing it out. A positive bx divided by b leaves you with just x. And factoring out a b from by, you're really just dividing it out. By divided by b, you're just left with plus y. Once you're here, now we've got 2 terms, right? This is all one term, and this is all one term. So factoring out what they have in common now, you're looking for a GCF between the 2 terms we have left. They have an x plus y in common, right? A times x plus y plus b times x plus y. They have an x plus y in common. So we're going to factor that out. That's like the GCF of this group here. So that GCF is going to be x plus y from these 2 terms. That's what they have in common. So we're going to factor x plus y out here to the front. And then if I factor out x plus y, we want our second set of parentheses to have whatever's left over inside of it. So we're going to have just a plus b. The way I like to think about this is I say, okay, what matches between the 2 terms? Well, x plus y matches, that's going to go in front. What's left over? A plus b, that's going to go in your next set of parentheses. Once we've done that, we factored it. Remember, when you're factoring, you want things to be multiplied together, and these are multiplied together. This is a very general example. I'm going to take you through the step-by-step process, and then we'll do a couple more. So, our steps for factoring by grouping. And remember, it's very important that you do this only when you have 4 terms. Alright, so that's what's telling you to use this method. Alright, so our first step says, determine if there's a GCF for the entire expression. If so, factor it out. In the last one there wasn't, but if there's a GCF common to all 4 terms, you want to factor that out to the front first, and then follow the rest of the steps for the remaining part of the factoring. Step 2, arrange the 4 terms into 2 groups of 2 terms each. Each group must have a GCF. This is what we did when we said, okay, the first group of 2, the ax plus ay, had a GCF of a, and the second group had a GCF of b. Step 3 was factor out the GCF from each group of 2, and that's what we did when we had a out in front times x plus y, and then plus we factored b out in front times x plus y. And then if the 2 terms formed in step 3 have a GCF, then factored out. This is where we factored out the x plus y to the front, and then our second set of parentheses had whatever was left over, the a plus b. So, let's take a look at another example. We're asked to factor x squared plus 6x minus 4x minus 24. When you're looking at this, first you should notice, is there a GCF for the whole thing? And when I say GCF for the whole thing, I mean a GCF other than 1. And right now we don't have a greatest common factor other than 1 for all 4 terms, so we can't worry about that. The fact that we have 4 terms tells us that we're factoring by grouping. So I'm going to take that first group of 2 and the second group of 2. And from this first group of 2, I'm going to factor out a GCF of x. right? Because x squared has a factor of x, and so does 6x. So the first, so it's the greatest common factor here is going to be x. For the second group of 2, we got negative 4x minus 24. Alright, so if I'm looking at negative 4x and a minus 24, what they have in common, you really want to base it off of, the numbers here first. There are no x's in the second one, so you can't factor out an x, but 4 and 24 have a greatest common factor of 4. And since this first term is negative, and it's all based on this first term, it has nothing to do with the second one, since this first term is negative, we're going to factor out a GCF of negative 4. So, this is going to be equal to, factoring out an x out of the first group of 2, we're going to factor x out in front, and really remember, when you factor out something, you're really dividing it out of each term. So x squared divided by x is going to leave me with an x here, plus 6x divided by x, you're going to be left with plus 6. And now, right here, we're going to put whatever my GCF was for my second set of 2. Remember, you have to take the sign with it, and it's all based off of that sign. So this is a negative 4, so we're going to put minus 4 here. And then our parentheses, remember, you're dividing it out. So it's a negative 4x divided by a negative 4, that's going to leave us with a positive x, right? And negative divided by a negative gives you a positive. Negative 4 over negative 4 gives you 1. The x just doesn't divide by anything, so it's going to stay there. And then negative 24 divided by negative 4, well, negative divided by negative, that's going to make that a positive well, so it's going to be a plus 6. Once you're here, now you want to see what both terms have in common. Remember, this is all one term now, and this is all one term. And they have an x plus 6 in common, so that's our GCF that comes out front. So we're bringing x plus 6 out to the front because that's what they have in common. Then my second set of parentheses, whatever was left over, x minus 4. Alright, and it's important to have parentheses here because you're showing that you're multiplying these together. Once I'm here, I'm done. I've actually factored it. I have two things that are being multiplied together. Remember, that's your goal when you're factoring, is to have things that are being multiplied. And you could always check this by foiling. Alright, and to check this by foiling, you would distribute through to each piece, and then you would see that you would get these exact same terms. Let's take a look at one more. Alright, so we're going to factor 6x minus 15xy plus 8y minus 20y squared. Alright, so again, the first thing you should do is look for GCF for the entire problem if one exists. In this case, 6x, negative 15xy, 8y, and negative 20y squared, they all don't have a common factor. So you can't factor out a GCF from the whole thing. Since we have 4 terms, alright, we're going to use factoring by grouping. So that's our first group of 2, that's our second group of 2, and we're looking for a GCF from each group. First I would look at the numbers. 6 and 15 have a GCF of 3, right? 3 is a common factor to both 6 and 15. And then look at the variables. Well, x and x, well, they have an x in common. There are no y's in the first term. There is a y over here in the second term. Since it's not in the first term, though, you can't factor it out. So the GCF for the first group is going to be 3x. For the second group, we've got 8 and 20. They have a common factor of 4. And then y and y squared, well, they have a common factor of y. So the GCF for that second group is going to be 4y. It's positive because the front sign of it is positive. That's what tells you the sign to use. So now let's factor the GCF from each group. So we're going to have 3x times, and then in the parentheses here, remember, you're going to just divide out the GCF from each term. That's how you're going to figure out what's left in the parentheses. So 6x divided by 3x just leaves you with a positive 2, right? 6 divided by 3 is 2. X divided by x, they cancel out to a 1. So we just have 2. And then minus 15 divided by 3 makes us a minus 5. X divided by x cancels out, and then you're just left with minus 5y. Here we're going to write a positive 4y, because that first sign's positive, so we need a positive here, so this is plus 4y. And then parentheses, 8y divided by 4y is going to just give us 2, right? 8 divided by 4 is 2. Y divided by y cancels to a 1, so we just have 2 there. And then minus 20 divided by 4 is going to be a negative 5. Y squared divided by y is just a y. Once we're here, now we've got 2 terms, right? And we want to take what they have in common. So what matches between this term and this term? Well, they have 2 minus 5y in common. We're going to write that out in front. Make sure you keep the parentheses around it. And then your second set of parentheses, since you're factoring inside of each, you're going to be left with 3x and a plus 4y. So 3x plus 4y. Remember, you need those parentheses there because that signifies that you're multiplying. And that's it. Then you're done. You're multiplying these together, so you factored it. To check this, remember, you can always distribute through by foiling and making sure you get the original expression. Alright, we're just going to take a look at a few more examples here. So, if I said to factor and I gave you 5x squared plus 30x minus 3x minus 18. Remember, the first step you want to do is always look for a GCF when you're factoring. So if I'm looking at GCF, I'm looking for a GCF for the entire thing, right? So for all four terms. And in this case, there is no GCF other than one, so I don't have to factor anything out. So then I notice how many terms I have, and in counting the terms, because I have four terms, that tells me I want to try to use factor by grouping. So we're going to split this up into two groups of two, and we're going to look for a GCF from each group. For the first group, the 5x squared plus 30x, 5 and 30 have 5 in common. X squared and x, you know, the GCF for those would just be x, because remember you want the lowest power you see, because it's the highest one that's common to both. So we have 5x for the GCF for the first group of two. For the second group of two, remember, first term being negative means you're definitely taking out a negative. And then you're comparing a 3x and 18. 3 and 18, the GCF is 3. Here we have an x, but there are no x's in the other terms, so you can't take any x's out of there. Remember, it has to be common to all terms. Once we have a GCF from each group, now we factor it out. So I'm going to factor 5x out from the first group of two. So you put 5x in front, then parentheses, and then remember, you're dividing each term here. 5x squared divided by 5x is just x, because 5 divided by 5 is 1. X squared divided by x is just x, so it's 1x, which you just write as x. Positive 30x dividing out of 5x makes this positive 30 divided by 5 is 6. The x's will cancel to a 1, so just x plus 6. Remember what goes here, whatever you had here based on this sign. So this is a negative 3, and then in parentheses. Now make sure you have the sign here. If you don't have the sign, it's not correct. So minus 3 times, and then in parentheses here, when you divide this, make sure you divide the sign with it. A negative 3x divided by a negative 3 makes us a positive, just 1x, or just x. Negative 18 divided by negative 3 makes us a positive 6. Now, once you're here, remember when you're factoring by grouping, you're looking for a GCF to both terms. Remember, this is all one term, this is all one term. You want to find what they have in common. They have x plus 6 in common, and then whatever's left over from the front of each of them. In other words, when you factor out x plus 6, what's left over here? Well, just 5x. When I factor out x plus 6 from here, what's left over? Just negative 3. And we're left with a product at the end. X plus 6 times 5x minus 3. All right, make sure you have parentheses around both of those because you're multiplying them. Taking a look at a couple other ones. If I said to factor x squared minus 3x plus x minus 3. Again, first thing you should do when you're asked to factor is look for a greatest common factor. In this case, for all four terms, I don't have a greatest common factor other than 1, so we don't have to factor anything out of there. When you look at this, then you want to say, okay, 4 terms tells you try factoring by grouping. For x squared minus 3x, the GCF here, well, this is a coefficient of 1 and 3, so it would only just be a 1. X squared and x, they have an x in common, so just x. Here, I've just got x and 3. It's a positive, so I know the value I'm factoring out should be a positive. X and 3 don't have any common factors other than 1. In this case, you do want to write the 1 here because you're going to need something for your next step when you factor it out in terms of a value. It's going to be part of your second factor at the end of the problem. If you don't put anything here, you won't know what to factor out. So if it doesn't have a GCF other than 1, you want to write a 1. If this had been a negative sign, right, the first term being negative would tell you to take out a negative 1. So once I'm here factoring out x from the first group of 2, x squared divided by x gives you just x to the first power, just x. Negative 3x, factoring out the x, just gives you negative 3 because your x's will cancel. Here's a positive 1. Make sure you put a plus sign because it's positive 1. You need the operation there. You need the sign of the number to use as the operation. So a positive 1, when you factor 1 out of each of these, well, positive x divided by positive 1 is still x. Negative 3 divided by positive 1 is still negative 3. Once you're down here, now you can say, okay, I have 2 terms remaining, and I want to see, do they have anything in common? Now, if they didn't have anything in common, you would just not be able to factor it. It actually would be unfactorable. But in this case, they do have a factor of x minus 3 in common. And then remember, the way you fill in the second part is whatever's left over from the front of each of these. If I factor x minus 3 out of here, I'm just left with x plus factoring x minus 3 out of here, I'm just left with plus 1. So we have x minus 3 times x plus 1. Again, it's a product at the end. It should be things that are being multiplied together when you factor. So keeping in mind that if you didn't put this 1 here, you might not have put it here when you factored it out, and then you might not have had anything here. So the common mistake people make is they just put x minus 3 times x, and they forget that they actually factored a 1 out of this. Make sure you do it. All right, it's very important. We'll just look at a couple more. If I said to factor 2x squared minus 6xy plus 8xy minus 24y squared. Remember, your first step when you're factoring is always to look for a GCF, a greatest common factor, for the entire thing, so for all 4 terms. Now in this case, is there a GCF for all 4 terms? Make sure you're being careful here, because if there is one, you should factor it out. And in this case, we do have 2, 6, 8, and 24. Those have a greatest common factor of 2. X squared, x, this doesn't have any x's in the last term, so you can't take any of those. These last 3 terms have y, but this doesn't have a y, so you can't take any of those. So the GCF is just 2. If there is a GCF, you factor it out first. So the first thing I'm doing is I'm going to write 2 here. Now when I factor it out, remember how this works. You're factoring out the entire thing. So you're taking 2 out of each term. So 2x squared dividing by 2 or factoring out of 2 gives me x squared. Negative 6xy dividing by 2 gives me a negative 3xy. Positive 8xy divided by 2 is a positive 4xy. And then negative 24y squared, factoring out the 2, makes this negative 12y squared. Now once you've taken out a GCF, as long as you took out the greatest common factor, that greatest common factor the entire time through the problem will stay in the front. At the very end of the problem, you should have a 2 in the front of this problem. And then you want to work inside the parentheses. So once you've taken out a GCF, you want to work into these parentheses here. In these parentheses, keep in mind, now you're counting the terms. I have 4 terms here, and if I have 4 terms, that tells me maybe I should try factoring by grouping. So if I try to factor by grouping, make 2 groups of 2. In the first group, you're looking for a GCF, just like we did before. Well, what's the GCF of this first group? The GCF here, x squared minus 3xy, they share just an x in common. For the second group, 4xy minus 12y squared, it's positive, so you know it's positive there. 4xy and 12y squared, well, 4 and 12 share a common factor of 4. There's x's here, there are none here. We have a y here and a y squared. Remember, you can take a y out because you want the lowest power of the variable you see. So when I factor this out in here, make sure you're paying attention to what's happening. These big parentheses are separating the 2 from what you're doing. Then in here, you're going to do what you normally would. So be very careful. This x is what you factored out. You're factoring from each of these terms. X squared divided by x gives me x. Negative 3xy divided by x is just negative 3y. Here, remember, you need an operation. This is a positive, right? So you need a plus sign, right? So positive 4y. If it had been negative, you would have taken a negative out, and that would be negative. But since it's positive, we need a plus sign there. When you factor out 4y from each term, 4xy factoring out 4y just leaves you with just x. Negative 12y squared, factoring out 4y. Negative 12 divided by 4, it's going to be a negative. 12 divided by 4 is 3. Y squared, taking out the y, leaves you minus 3y. Close that parenthesis. So you've got these big parentheses separating the 2, and then everything else in here is what you normally would do when you're grouping. So in my next step, remember, 2 in front GCF will stay 2 in front. The entire problem, it'll be like that. 2 stays in front. And now we're going to look at what's happening inside of here. So when I do factoring by grouping, I'm left with 2 terms, and I'm hoping to see a common factor between them. Well, what do these have in common? They have a factor of x minus 3y. So I can write that in parentheses right after it. And then what's left over from the front of each? Remember, this 2 is on the outside of it. You're just using this x plus 4y, right? When you factor out the x minus 3y from here, there's just x. When you factor out the x minus 3y from here, there's just 4y. And this would be your final answer. You don't need this large set of parentheses anymore because it's all a product right here. It's all being multiplied. You could put a parenthesis in here and here, but since it's all multiplication, you don't need that extra parenthesis anymore. Here you did need it because you separated the 2 from this x. The common mistake people make is if they don't separate it with these big parentheses like we have on the ends, they put a 2x here, and then the 2x gets buried inside of one of these terms. So make sure when you take a GCF out at the beginning of the problem, it's going to stay out in front the entire way through to the very, very end. All right, and we'll look at just one more like that, just to make sure we got it. If I said to factor 9x to the third power plus 6x squared minus 45x squared minus 30x. Whenever you're factoring, the first thing you do is look for a greatest common factor. In this case, 9, 6, 45, and 30. Well, those all have a greatest common factor together for the coefficients. 9, 6, 45, and 30 all share a common factor of 3. For the variables, I have x to the third, x squared, and x. Well, that means that you can also take x to the lowest power you see, which is x to the first power. Remember, it has to show up in all the terms in order to be able to take a greatest common factor out. So we can take an x out in this case. And remember what you do. You take out the GCF, you're going to write it in front. So you've got 3x. And then in parentheses after it, remember, you're taking it out from all the terms, right? That's what it means when we factor out a GCF. So 9x to the third, factoring out 3x means divide by it, gives you 3x squared. A positive 6x squared, factoring out the 3x, or dividing out of 3x, gives me a plus 2x. Negative 45x squared, factoring out 3x. Negative 45 divided by 3 is negative 15. X squared, factoring out one of the x's, just gives me negative 15x. And negative 30x, taking out the 3x, leaves me with negative 10. Now be very careful here. If you didn't take out both the 3 and the x, you wouldn't have taken out a greatest common factor. You'd only taken a common factor. If you only take a common factor, it might not work out for you at the end of the problem in terms of your grouping. So when you take a GCF out, remember from the last example, that GCF will stay out in front. So that just stays 3x in front. And then I've got this big set of parentheses that's separating the 3x from everything else, right? Separating my GCF out. And now you want to make two groups of 2. And we're doing that because we have 4 terms, right? 4 terms is telling us we're going to try to do grouping. From the first group of 2, greatest common factor, 3 and 2 only share a common factor of 1. X squared and x share an x, so 1x is just x. Here we got negative 15x minus 10. The first term being negative. It has nothing to do with this second negative sign. It has everything to do with the first term being negative. It tells me I'm factoring out a negative. 15 and 10 share a common factor of 5. There's an x in the first term. There aren't any in the second term, so you can't take any x's out. Remember, it has to be common to both. So when you do this, inside this big set of parentheses, we're going to do our factoring by grouping like we normally would. We have x out in front from this x we're factoring out. 3x squared plus 2x, factoring out the x, where you're dividing it from each term, gives me 3x plus 2x, taking out the x is just plus 2. Remember, you write whatever you factored out here with whatever sign you had, so this is a negative 5, which makes it minus 5. That's why it's important. If you don't have that sign, it's not correct. And then in parentheses after it, you're factoring it out. Negative 15x dividing out a negative 5. And you really should think of it as dividing because that gives you the sign. So negative divided by negative makes it a positive. 15x divided by 5 gives me just a positive 3x. Here, negative 10 divided by negative 5, well, that's a positive, so it becomes plus 2. And then close that parenthesis. The big parentheses, again, are separating the 3x. So in the next part of your answer, right, as you keep working through this, the 3x in front, remember, GCF in front stays in front. And then from there, you're looking at what you have, and you say, okay, inside of here, I've got 2 terms, and they have what in common? Well, they have 3x plus 2 in common, so you factor that out. And then parentheses after that, you want to put whatever's left over from each part, which would be the x minus 5, right? Factoring 3x plus 2 from here is just x. Factoring 3x plus 2 out of here is just minus 5. And again, you don't need the big set of parentheses here because now you have a product. It's all multiplication. Prior to that, it wasn't all multiplication. You had a subtraction in between. Since it's all multiplication, since it's all a product, we are factored completely. Something to note, if you didn't take a GCF out at the beginning of these last 2 problems, the grouping might have still worked for you. You would have been able to factor it down. You would have gotten 2 sets of parentheses at the bottom. The only difference would be is that 3x didn't get taken out. So the 3x would have been buried in one of these terms in here. So you would end up with something like 9x squared plus 6x
or you might have had the 3x in here, which would be 3x squared minus 15x, and you would have had to have noticed that you needed to factor out at the end. If you don't factor it out at the beginning and you left it in there and it's stuck in one of these terms at the end, you wouldn't get full credit for that because it's not factored completely. Remember, when we say factor, we mean factor completely. So hopefully these examples helped clear things up about factoring by grouping. The main things to remember are the first step is always to look for a GCF for the entire expression that you're given. And then the second thing to remember is that when you have 4 terms, that's telling you to try to use factoring by grouping. All right, hopefully this video was helpful.